All right, here we back are with part two of section 15.5, which is the gradient. So what I wanted us to look at here is this vector with our two partial derivatives, because this is a really interesting vector. And it does have a special name. I bet you can guess what it is because it just said it. It is the gradient. So if f is a differential function at a point, the gradient is our vector valued function. Our partial derivative with respect to x is the first component, and the partial derivative with respect to y is the second component. So again, the thing to notice about this is talking about a 3D function, but the vector that we get is a 2D dimension, or 2D vector, and it lives in the xy plane. And, also remember that that's where our level curves live. So if, again, that level curve is those altitudes. So if we say, let's look at our function when our output is always 5, and then we kind of draw around where it's always 5, that's our level curve. So if we put those down in the xy plane, our gradient vector also lives in the xy plane. We'll have this make sense here in a second. Other things to notice about this and to think about is that our directional derivative at some point xy is that vector, that partial derivative vector times our unit vector, or not times, dot product with our unit vector u. Well, we just said up here in our definition that this is the gradient at that point. Oops, too many parentheses. This is the gradient. And then dotted with our unit vector. So now we know from way back at the beginning of the term, the dot product, this might have been second day of class, it's the magnitude of each of our individual vectors times the cosine of the angle between them. So theta is the angle between the direction and that gradient. So if we think about this, first off, u is a unit vector. So this is equal to the gradient, the magnitude of the gradient, times the cosine of the angle between them. So let me grab a different color here so that I can say that the magnitude of u is 1. That was one of the main reasons why we set this up so that u, the direction that we're going in, is a unit vector, because then when we look at this dot product, that's 1. Now, the other thing to think about here is cosine of theta. We get here outputs between -1 and 1. Those are the values of cosine. The smallest value, or the least value that we get out of cosine is -1, and the largest value that we get is +1. So if we were thinking about that directional derivative, again, because that tells us the slope of our surface at that point going in that direction, when the slope is going to be the greatest is when the cosine is equal to 1. Well, when that happens, we just get the magnitude of that gradient. So that leads us down here to our sort of interesting facts about the gradient. So we've got that f is differentiable at our point AB, and our gradient's not 0. And so our function has the maximum rate of increase at that point in the direction of the gradient. And that maximum rate of increase is the magnitude of the gradient. So if we go in the direction of the gradient, that is going to give us the biggest increase that we have. And our maximum decrease would be going the opposite direction. So if we went the opposite way, we would get the biggest rate of decrease. And the actual value for that would be the opposite of the magnitude. And our directional derivative is 0 in any direction that is orthogonal um, to our gradient. All right. So sorry, I'm moving around here a little bit. So let's say we're given a function in 2 dimensions and we stand at the point 3, 0 in the xy plane. And we want to know if we project ourselves up onto our 3-dimensional graph, which direction should we walk in if we want to get the greatest increase, and what is that rate of change. So this is really just a fancy way of asking us, whoa, let's see, asking us what is the gradient. Sorry, I had my iPad in kind of a weird spot there. So our gradient, sort of our general gradient, is again that partial derivative of x is the first component, partial derivative of y is the second component. Oops, let's make sure we get that as a vector. Then if we want the gradient at that particular point, that again is just a matter of now us plugging the point 0, 3 into our gradient vector. So we're going to get -6 and 0. So this is the direction we should go to get the greatest increase. This is going to be our sort of most steep uphill path that we can go, is what that's telling us. And if we wanted to know what was that rate of change, that's going to be the magnitude of our gradient, which in this case is going to be 6, right? Because we're going to get square root of 36 plus 0. So picture-wise, what's happening here, if we're looking at the xy plane, so there's x, there's y, and the point that we're kind of talking about or concerned about here is the point right here, 3, 0. And if we look and think about our three-dimensional function here, we are going to get that we're looking at when we have an altitude or an elevation, that's the word I want to say, an elevation of 0. So if we wanted to make the level curve that this point sits on, if we set our equation equal to 0, now we get a circle. So this is a circle. Its center is at the origin and its radius is 3. So this is the level curve for when z is equal to 0. All right, so what we found is our gradient was this vector -6, 0. So that's telling us to go in the direction of -6, 0. -6, 0 is, sitting right here at the origin. It goes off this way and it stops here at -6, 0. So if we take that vector and move in that direction, starting from the point 3, 0, so I'm going to kind of move that here. All right, if we move in that direction, right there, that is the direction that we need to go in. We need to go right along the x-axis or parallel to the x-axis on our graph. Now, what I want you to notice about this, something interesting happens here, is if we look at the tangent line to our level curve at that point. So this blue line is our tangent line. Oops, can't spell tangent today. Tangent line to the level curve at that point 3, 0. If we take a look at that blue line in our red vector, hopefully we notice that those two guys are perpendicular. And then this, brings up that question, is this always true? Actually, yes, it is always true that the gradient is going to be perpendicular or orthogonal to the tangent line of the level curve. And so this is telling us to go this way, and this is where we're going to have our steepest slope. So we'll see if I can do this. I didn't set this up beforehand. So let's see. Let's draw this graph here really quickly. So 9 minus, I just want to take a look at it and just make sure that this makes sense in terms of, yes, if I go in that direction towards the point -3, 0, excuse me, kind of lost my train of thought there while I was graphing. Okay. So here's our picture here. I don't know if I can, and I think that I can get a point to plot on that. Graph, maybe we can get, not that, enter a trace point. Oh, okay, good. So 3, 3, whoa, I need to get a parentheses in there. Oh goodness, I cannot do the shift button. There we go. Whoa, sorry guys. 3, 0. We actually know the output is 0. Okay, so I just want to put that trace point on there. Oh, I wanted to show the trace point. Show the trace point. No, it's not going to show it on there. Boo. All right. Well, our point is right here on the x-axis, and it's telling us to go back towards the negative x-axis, and that's going to give us our steepest slope. So if we go in that direction, that is going uphill the steepest way we can from that point. And if we go the opposite direction, which would be going, down along that path there, then that would give us the steepest in the downhill direction. Okay. So, this means that we can draw some level curves on and then draw the gradient onto our level curves, because that gradient is always going to be perpendicular to that level curve. So say we've got the level curves. So this is a three-dimensional function where I just drew the level curves and then took a picture of it. And if I want to draw the gradient at that bright blue point there that we have, sorry, it's not like the most beautiful thing. We're wanting to look at, sort of right there, right here. And the way that I like to do this is I like to draw in that tangent line, because that is really easy for me to visualize what a tangent line is. I'm sort of used to that. I'm used to drawing those tangent lines and going, okay, it's got to go just skim right along that graph right there at that point. So there's the tangent line. Oops, let's get a color we can actually read handwriting in. So there's our tangent line. The gradient is going to be perpendicular to that tangent line, and we need to be going uphill. The gradient's going to go uphill. It's giving you your greatest rate of increase. So if we look at these level curves, this first one here is 4, this one that we're sitting on is 5, this one's 6, and this one's 7. So it's going to have to go in the direction of that 6 and 7, because that means we're going uphill, that our outputs are getting bigger, our elevation is getting bigger. So this is the gradient. If we wanted to go in our direction of the greatest decrease, we would go in the opposite direction from that. This guy here, that's our biggest downhill direction. So this is the opposite of the gradient. And we could do this for any point on any of these little curves. We could go over here and grab a point on our level curve and, draw in that tangent line, and then draw in a line perpendicular to that, and that's going to be our gradient. So we want to go, again, the way that those level curves increase, sometimes that's in, sometimes that's out. In this last picture, whoops, in the first one that we had, our graph gets steeper as we go in towards the center. And we can see that from that three-dimensional graph. So that's telling us to go in towards the center. This one does something slightly differently as we go out away from kind of the center there of that kind of oval, those oval shapes. That's how we're getting steeper. So you want to watch your numbers and say which way is going to be the more positive direction. So we'll definitely take a look at some more of these kinds of things in class, but this should give you a good head start on the gradient.